Howdy. Welcome to another episode of Dinosaur Parkour. Faster, better mainframe programming. The topic for this video is Edit Profile, how they're named and managed. I'm your host, Chris P. Fried. This shows the version of ISPF that was used to create this video. ISPF for ZOS 2.4, which is also known as ISPF 7.4. Type 3 for utilities. Type 4 for DS list or dataset list. This is the dataset list utility panel. I want to show all of the datasets that have a high-level qualifier of my TSO ID Z08115 and has a second node of Dino. The initial view of the next screen is to show the attributes of the matching dataset. The include additional qualifiers means that dot asterisk asterisk is appended to the DSN name level. Using double asterisk for a node is a wildcard for 0 to many nodes. Press enter. First, notice that some of the datasets have more than 3 nodes. That is the impact of the additional qualifiers option. When a dataset or library is edited, an edit profile is used to track your edit preferences. How does ISPF determine the name of the edit profile? There are 3 parts to a profile ID: the profile name, the record format, and the data length. Regarding the profile name, if one is not provided, ISPF uses the last node of the dataset name. This screen shows the edit entry panel. The profile name is blank by default. This is one place where a specific profile name can be provided. Most programmers rarely use that field. This screen shows the dataset list string. An E for edit has been placed beside the JCL lib. Unlike the edit entry panel, there is not a way to enter a profile name on this screen. Therefore, the system is going to use a default name for the profile name. This is showing the profile information for JCL lib. The profile ID is JCL lib plus fits plus 80. The profile ID is comprised of 3 parts: the profile name, which is generally the last node of the dataset, the record format, fixed or variable, and the data length. Let's go back to the dataset list. For the dataset shown here, there are 4 profiles: COBOL fits 80, JCL lib fits 80, RETS lib fits 80, and PDS lib fits 80, which is used by 3 of the datasets shown here. Hit PF3 to exit out of this panel. We're going to change the search criteria. Z08115 plus asterisk plus test lib, ending with an implied dot asterisk asterisk. Enter. 8 datasets are returned. All 8 datasets end with a node of test lib. This list of datasets use 8 edit profiles because each dataset has a different combination of record format and record length. They all use the same profile name of test lib, but the other 2 parts of the profile ID, which is record length and record format, are different. Edit the variable block 4096 library. E for edit. Enter. The profile ID is test lib plus variable plus 4092, not 4096. The L record is 4096. but the first 4 bytes are used by the system to store metadata about the record. Those 4 bytes are known as the record descriptor word. That leaves 4092 bytes for the data. So the profile ID is the profile name plus the record format plus the data length, not the record length. I'm going to press PF1 for help and bring up a help that I find confusing. This is the help section that explains how to identify and edit profile. It says what has already been explained. However, this implies that only data lengths between 10 and 255 are valid. This profile ID is test live variable 4092, which is greater than 255. I allocated a library with a data length of 16,380 and an edit profile was created. So it seemed to me that the help for how to identify an edit profile is incorrect. The edit profiles are stored in the ISPF profile dataset, which is assigned to the DD ISP Prof. CHOP can name this dataset slightly different. In my experience, the first node is always the TSO ID, and it's pretty common for one of the nodes to be ISPF Prof, which is the DD name. I'm used to it being the last node as shown here. Press enter to edit the member named ISR Edit, which is where the edit profiles are stored. Issue a find command on TestLib. The first test lib is for variable block 16,384. The data length is 16,380. That's the data set I mentioned a few seconds ago. JCL Live Fix 80, COBOL Fix 80, Test Live Variable 4092. The profile information is not human friendly, but the edit profile IDs are easy enough to read. In the second part of how to manage edit profiles, another way to view the profiles will be shown. The total number of profiles can be configured by a system programmer. However, most shops take the default, which is 25. That sounds like a lot until you consider that the last node of a data set is part of the ID. Factor in the different data lengths, and 25 is not many at all. Personally, I only use 3 profiles on a regular basis. RETSLive Fix 80, which contains RETZet and JCL for them. And when I create a RETZet that uses a panel, I will allocate a panel library. That's my second one. And the third one is PDSLive Fix 80, which contains COBOL and assembler programs, copybook, PARM, JCL, etc. PDSLive is my catch-all node. My main library used for making these videos is z08115.dino.pdslib. I only created a JCL library because something else I was doing required it. I don't plan on keeping it. If I'm working on a specific project, I create a PDSLive for that project. For example, I plan to make a video on how to use unbounded table. I allocated that last library for that project, which is z08115.dino.unbound.pdslib. I will attempt to store everything for that project in that library, program, copybook, PARM, JCL, etc. That empty PDSLib was created because I needed an empty library for a task, and ending libraries with PDSLib is what I normally do. Let's look at the profile for RETSLive. It has been customized the way I like, and it has been locked. Locking a handful of profiles is how one can make 25 enough. When the max number of edit profiles has been reached and a new one needs to be saved, ISR Edit replaces the oldest reference profile that is unlocked. You should not lock all your profiles. Only lock the ones you commonly use. This RetSlab Fix 80 profile is not going to be deleted because it's one of just a handful that'll lock. Having the last node of a library denote the type of data it contains helps with profile management. Here are some of the common profiles and the type names I have seen. The job JCL might be in a separate library from the prop because the scheduling software needs access to the run JCL. PARMs or control card libraries are very common. Libraries for copybooks and similar includes are common. And there are libraries to hold the source code for the various programming languages. Notice that COBOL seems to be treated differently from other sources. One of the edit options is number. The number option can be configured to place line numbers in columns 1 through 6. If that is done, the COBOL source needs to be stored in a COBOL specific node type such as COB, copy, or COBLib. I mentioned that I use PDSLib for all my source type, COBOL, Similar, JCL, PARM, etc. I am able to do this because the edit option called number is turned off. A common library for multiple types of source does not work smoothly when the number option is on. Number on standard does not work for RetSZ. Number on COBOL only works for COBOL source. This is the edit entry panel. The ISPF library section is project, group, type. That means IBM expects libraries to be named in the form of project.group.type. I'm going to go ahead and declare that getting a new high-level qualifier for every project is rare in my experience. I work for a company that provided services for various customers. The customers might request something new, and that would be a new service or function rather than a new product. There's a lot of paperwork to get a new high-level qualifier defined. At my prior shop, it was not common to create high-level qualifiers for projects. It was normal to create high-level qualifiers for customers, but not for projects. The storage group has to agree to create a new high-level qualifier, order the storage, define the SMS rules, and create the disaster recovery process, etc. The security team had to define the rules to protect the data set, determine who can approve access, etc. So there's a bunch of politics involved with the required paperwork. The values that go into the project field are going to be controlled by how your organization manages high-level qualifiers. With that said, it is very possible there is a high-level qualifier for personal source libraries in your organization. For the purpose of this video, the HLQ for source libraries is going to be SRC. If the second node is somebody's TSO ID, the library might automatically be backed up. My prior shop had rules like that. src.z08115.pdslib would automatically be backed up. src.dino.pdslib would not be backed up automatically. The process for managing source libraries varies by organization. As stated earlier, the project and group nodes tend to be impacted by how the storage and security group control things. The type node is mostly used as IBM intended. The last node of a library should denote the type of data stored in it. src.test.coblib is where a programmer makes changes. When complete, the code might be moved into src.prod.coblib, which is used to compile the code into src.pod.loadlib. src.pod.jcllib might contain jobs that execute those programs from the load lib. All of those libraries had 3 nodes, but more is okay. src.dino.sum.theme.pdslib and src.z08115.un.bounded.table pdslib. Those 2 prior examples are using the extra nodes in the middle to denote the project or cache the library contains. When the last node denotes the type of data in a library, it can be used as an edit profile for that data. Edit profiles are much easier to manage when a programmer follows that guideline. So, the basic guidelines for managing edit profiles are: 1. Make sure the last node of the library denotes the type of data stored in the library: parmlib, jcllib, sourcelib. Lock the important profiles after they have been configured, and do not lock all profiles. Leave several unlocked to accommodate the various data sets that end with weird nodes. For example, src.code.fromxyz, where xyz might be a company name or ID. Wait, do not lock all of them? What if I lock them out of habit? How can I tell what my edit profiles are and how many are unlocked? I'm going to cliffhang this video. Look for a follow-up video titled How to View Your Edit Profile. This has been another episode of Dinosaur Parkour. Faster, better, mainframe programming. Thank you for listening. If you're not already a subscriber, there should be a subscribe icon on the screen. If you found this video useful, please consider becoming a subscriber.